Hey everyone, it's Robert Curtis here from Distance Calculus at Roger Williams University. In this video, I'm going to talk specifically about data science. Now, data science is like a really hot job area right now, and if you go onto job lists like Indeed and all those other kinds of job places, you'll just see stacks and stacks of job listings for people who know data science. And so I'm going to talk about in this video what distance calculus has to do with data science. All right, now data science is actually just kind of a new term, and it's kind of like, let's call it this. It's programming, as in computer programming, plus statistics. And programming and statistics like as a package. You're a programmer and you're a statistician. But it's even more than that. It's statistician and a mathematician. Some people think, well, what's the difference between stats and math? Well, they really are two separate things. And in some universities, they're actually separate departments. There's a mathematics department and then there's a statistics department. And a lot of times, you know, there's some rivalry between those two academic departments. So when they talk about data science, they're talking about somebody who knows programming and also knows math, specifically a lot of mathematics and also a lot of statistics. So how do you get to the point where you can actually say you're a data science person? Or let's say you've decided that seems like something you want to do as a career. How should you prepare for it? Well, of course, there's the programming piece. You have to go study programming. Now, do you need to go do a bachelor's degree in computer science? Maybe not. Some degree programs, some jobs like to see that bachelor's degree in actually programming computer science. And some are just like, well, maybe you're just a programmer. Maybe you just learned how to do programming. But obviously, if you're interested in data science, it really does start with being a programmer. So I'm assuming that I'm talking to you, if you're watching this video, that you are some kind of programmer, either self-taught or you actually had formal training in computer science. Maybe you did a computer science minor or a major, or who knows? Maybe you just picked up some stuff on the side. I'm going to talk about these two things right here. What's the kind of mathematics that you need to go on and do data science? And the mathematics that you absolutely do need are the following. You need to do the calculus sequence, calculus 1 and 2. You also need to do multivariable calculus. You also need to do differential equations. And you need to do linear algebra. And you need to do probability theory, which is also called calculus-based stats. Now, you can do just, let's just jump to the last one here that's running off my screen, calculus-based stats. You can do just the probability theory. You don't have to take what's called the baby stat class. You can skip that one. It's the same topics actually, but it's just without the mathematics. Because they have lots of students taking those baby stat classes. Nursing students have to take stat classes. Accounting majors have to take stat classes. Business majors have to take stat classes. The calculus-based statistics, which is the probability theory course, is the same topics but done very mathematically using calculus to get at those topics. So you don't have to take this baby stat class, but you do need to take this advanced probability class. Now we offer all of these classes. Let's talk about all of these in sequence. So calculus 1 and 2, are you going to be using calculus in data science? Probably not, right? But it's Calculus 1 and 2 that gets you to multivariable calculus. Yes, you will be using a lot of the concepts in multivariable calculus and data science. Calculus 1 and 2 gets you to differential equations. Now, differential equations is an interesting one. It's not technically part of data science, but they're expecting you to have a very strong mathematical background. Differential equations is usually for physics students, for economics students. Those folks will go and do a differential equations course. But it does turn out that having knowledge of differential equations is very important in data science. Linear algebra is the big one here. This is the star of our show. And it's really the reason why, if you're going into data science, that they want you to have all of this mathematics. They want you to have linear algebra. Just that's the most important thing out of the mathematics sequence. But to get to linear algebra, technically you can just do calculus 1 and 2 and jump to linear algebra, but you really can't do it. You cannot cut corners if you're going to become a real data scientist and make the big bucks, right? They're going to expect you to have all of these classes and then some. And really, this class here is kind of where you start from, right? This class, the probability theory, this calculus-based statistics, is really the starting point of data science. And you're going to need to take a number of classes after this course. Now, usually those classes are offered in a variety of ways in data science study. But to even like crack open the start of learning the mathematics and the programming behind data science, they're going to assume that you have probability theory under your wings. So basically, to go and do a data science, you need to finish all the classes that we offer here at Distance Calculus, and that's kind of like the starting gun. Now, there's a couple of different ways of attacking these courses. If you look online, there are a whole bunch of MOOCs. Coursera, edX, MIT Open Courses. These are massive open online courses. And you will see a whole bunch of courses here on all of these calculus topics. So the calculus sequence you will find inside of these MOOCs. And remember, these MOOCs, these are free, which is pretty cool. It's pretty cool that there's a free set of classes. The problem is, as we'll discuss, is that they really don't offer any, they don't offer credits, which is really why you're watching this video and you're looking at distance calculus. So, the calculus sequence you can certainly take within the MOOCs. You can certainly do all the programming courses in whatever language you want, right? The big languages for data science are usually Python. That's the most popular. Right now, every year it changes. You know, every couple of years it changes. But for right now, Python is the programming language of choice. And then you can also start taking some of these data science type courses. So if you look around the MOOCs, you'll find a whole bunch of data science type courses. And what they're going to do is they're going to start off in these courses and they're going to assume a couple of things. They're going to assume that you have some programming experience under your belt, and they're going to assume that you've already completed the calculus sequence. So one thing that people do when they sort of like homebrew becoming a data science person is that they'll go through the calculus sequence in these MOOCs, which is not bad, but it's not really any different than like going to the library and getting out some of these calculus books and sitting down and reading them. That's kind of the harder way to learn calculus. Some people do it. And the programming courses as well. Once again, it's a little bit harder to learn just by going to the library and getting a book on Python. It's much better when you're in a class, you're hearing lectures, you're being asked to do certain assignments. Those assignments are being graded. That whole learning process is slightly better. So you can do all these things from the MOOCs, all right? Now, what is your end-up goal here when you want to be able to say that you are a data science, a data science person? There's two different ways to go. You can go for a data science certificate. And there are a lot of programs out there now that you can find online that advertise that you'll be able to complete some set of courses from them and at the end get a certificate saying you've completed this training in data science. Now, those certificates are very good to have. You can go to an employer and say, look, I finished the data science certificate at UC Berkeley. That's not bad. I mean, that's really good. That's a good thing to be able to do. These certificate programs, they really do fit in with the MOOCs because neither of them are offering academic credits, which may be important, it may be not. But let's talk about on the other side of the coin. If you want to become a data scientist who actually has degrees in data science related fields, then when you're on the academic side, then you're going to be looking at things like this. A Bachelor of Science in Computer Science, perhaps. You can usually do a specialization in these computer science degrees in data science. And you might be looking at master's degrees in either computer science or data science now. You can do actual master's degrees in data science, or you might actually do it in statistics or applied statistics. So when you want to be on the academic side with a bachelor's or a master's degree that demonstrates that you are a real data scientist. And if you think about it, these certificates are very, very good and will likely get you hired. Having an academic chain of proof that you are a data scientist is even stronger. It's more difficult. You have to take more classes. You have to do them all for credit. But as we all know, right, certificates are just a step below the actual degree programs when you're going to go towards a job. If you're competing against other people for a job that you want, you can rest assured that an academic chain of degrees is going to be a stronger application than just the certificates. For a lot of people. A lot of people will go get a certificate if they already have a body of work in programming and that they can show a potential employer. Look, I'm a programmer. These are programs. These are web systems that I've already made. And now I'm branching off into data science and I went and got a certificate. I already have a bachelor's degree in econ or math or English literature. A lot of times people switch completely in their careers. But if you're looking for an academic path towards data science, you're going to be looking at things like a bachelor's degree in computer science or a bachelor's degree in math. You can also do a lot of math degrees with a data science concentration. And you might be going off to look for a computer science, a data science, or a statistics master's degree. Now, if you go off and do the MOOCs for your calculus and you do a a data science certificate, a fine experience, fantastic. These things are not going to go over and apply towards an academic program. They're simply not going to transfer. You need transcripts on this side, academic transcripts that actually prove this body of courses was completed by you, and getting certificates out of MOOCs and even programming certificates from various schools may not, certainly won't bridge this gap over into the academic proof of becoming a data scientist. So there are a lot of people who do this side, that's true, but this is the stronger side and will remain so likely for quite a while. All right, so all that being said, so suppose you agree with me at this point in the talk that you want to pursue courses for academic credit to prepare you for entering some sort of data science degree. How do you want to do those courses? There are the courses on the classical side of education, and then of course there are the courses here from distance calculus. How do these two relate to each other and compare to each other? Of course, we all know that, like, if you go to a college or university and you take calculus 1, calculus 2, linear algebra, differential equations, more times than not you're going to be working out of a textbook, and you're going to be learning the mathematics from a textbook, and likely no computer. Now, some courses in universities, in the higher courses, will have some computer work, but it's still not very standard. You could, and I'll just put computer work and then a question mark. Maybe there's computer work in these courses that you may take, and maybe there isn't. In distance calculus, of course, we are doing 80% of all of our work using the computer algebra systems. And in courses like linear algebra, we are using a very powerful software called Mathematica. And Mathematica is it's a programming language, but it's also a math tool. So you're going to be exposed to some programming, and then also have to do some copy and paste of some code in the course like linear algebra. And you're going to be working in these notebooks. So you can, in these notebooks, actually write C. You can write C code, but we don't, right? So we're using the constructions from Mathematica to draw graphs very easily. And one of the benefits of this course, and I'm just talking mostly about linear algebra now, because that's the big course for data science, is linear algebra, that from distance calculus, this course over here in linear algebra using Mathematica is very experiment based and very data based. It is not classical at all. It is all experiments, running experiments on matrices, different matrices, generating matrices, seeing what they do. How do they interact with vectors? What are they doing to the vectors? How are they taking a whole set of vectors and mapping them to another set of vectors? When you get done with the linear algebra course, which is actually very, very long, we have a lot of topics in that course because it's so cool, you are going to have not only sort of a programming course, and if you're a programmer on top of it, you're going to find it very appealing, that you're going to have not only experience with doing some programming in that class, but you're going to have a very modern approach to linear algebra that is experiment-based, that is data-based, versus what you might find in a classical linear algebra course in a classroom, which is going to be very paper and pencil-based. So we do some paper and pencil because you need to have some mathematics literacy in linear algebra, but it's just a minor amount. It's just 20% because you need to have some, but the majority of the work in the linear algebra course is all in Mathematica, and it is a beautiful class to bridge you into the study of data science, and it will really prepare you for starting your studies in data science, having that linear algebra course under your belt. This linear algebra course, a classical one, in a mathematics department in university. Those are excellent classes. They're beautiful, but they're really for math majors. They're really training math majors to go on to abstract algebra as juniors and seniors. And those are beautiful classes, but they're not really looking towards that class as a data science preparation class. Whereas our linear algebra class in distance calculus is definitely a data science preparation class. All right, well, that's just a little discussion about data science and how it fits in with distance calculus. If you have more questions about distance calculus, find me on chat or an email, and we'll try to help you as best we can. My name is Robert Curtis from Distance Calculus at Roger Williams University. We'll talk to you soon.